Hello everyone, and welcome to the fifth part of our intermediate webinar series, Making Figures with ggplot2, Colors and Saving Your Plots. In this section, we're going to review how to customize the colors of your figures and save your figures to a file using ggplot2. For our example data, we're going to be using the same assembly QC table from the previous section, and that is a table that was generated using the assembly QC program Quast. We're going to save it to a variable by reading it in using the read.delim function. Now, just to have a brief review, in previous sections we discussed that we can choose a single color for our plots, or we can color our plots by a variable within a column in our dataset. Plotting a single color is done outside the AES function. So this is an example that we've used in previous sections where we are plotting in 50 as a histogram, and I want to make the outline of this histogram black and the fill of this histogram light green. When we run this code, that is exactly what we get. Now, if no color was specified in this case within the geom function, ggplot2 will use black or gray by default, depending on the type of geom you're using. To color our plot by a variable within our dataset from a particular column is done with the AES function. So here is the same example, but this time we're coloring the histogram by species, of which there are 2 in our data set. So we get rid of the colors that are specified within geom histogram and instead say fill equal to species. And then we get this figure here on the right, where our Acinetobacter baumannii counts for N50 are colored in coral, and the Klebsiella pneumoniae counts are colored in teal. Now, if no color palette is given within the AES function when coloring a plot by a particular variable within our dataset, ggplot2 will use its built-in color palette by default, which is what we've seen thus far. Next, we're going to go over hue, chroma, and value. And hue, chroma, and value are part of what's called the Munsell color system, which describes the properties of color. I've included a link where you can read more about this here from munsell.com. Hue is how we distinguish and name the colors that are present on the color wheel, like red, blue, green, etc. Chroma is the saturation of color, and value is the lightness or conversely darkness of a color. Hue, chroma, and value of colors present in a plot can be changed using scale fill hue or scale color hue. And for an example, we're going to use a box plot that we've plotted in previous sections, where species is on our x-axis and total length is our y-axis, and we're also coloring the box plot by species. So the fill inside of the plot is going to be white, and the outline of the box plot is going to be colored by species, and we're not going to include any outliers. So hue is changed with the H parameter, and it can be a value between 0 and 360 because color in this case is chosen from the color wheel, so hence 0 to 360 because a circle has 360 degrees. And since we have 2 species in our data set and we need 2 colors for our box plot, we need to pass a vector of length 2 to the H parameter. Green is 120 degrees on the color wheel and purple is 270, so those are the values I'm going with. So we need to add the scale fill hue function, and within that function we need to give the vector 120 and 270 to the H parameter. And when we plot that, we now see that the color inside of our box plot is now green and purple for our Acinetobacters and our Klebsiella samples, respectively. Now, if we wanted to change the outline and not the fill within the box plot, we would change this to scale color hue, and we would give, again, a vector of 120 and 270 to the H parameter. And we also need to change fill equal to species to color equal to species. And when we run that, that's exactly what we see. We now have white box plots with a green and purple outline instead. Chroma is changed within the C parameter, and the maximum value varies depending on a combination of hue and value. And so to go back to our box plot example, if we wanted to change the fill hue, we would say C equal to 20 as an example within the scale fill hue function. I've just chosen that value at random, and now you can see that the hue of this box plot is different, and I'm also going to give C equal to 150 as an example again, and we see that the hue of these colors is now different as well. Value is changed with the L, which stands for lightness parameter, and it can be a value between 0 and 100. So I'm going to change the fill, which is still species in this case, to 90 as an example. So within scale fill hue, we set L equal to 90. And you can see that this is a much lighter color for the graph now. And then conversely, let's set L equal to 10. And now the colors within this box plot are much darker. Now, if you prefer to work with these values, you're absolutely welcome to, but I'm going to show you what I think is an easier way to change your colors next, and that's by manually choosing them. So color palettes can be chosen manually using the Scale Color Manual function and the Scale Fill Manual function. And these colors, when we pass them to ggplot, should be in the hex code format. So for example, I'm going to make two color palettes and I'm going to name them CP2 and CP4. One because I have a color palette that needs 2 values, and another because I have a color palette that needs 4 values. So these are the hex codes I've chosen, which are Studio Very Nicely colors for me. I chose these color palettes using a program called I Want Hue, which can be found at this website, but there are many websites out there for generating color palettes. Now the function Scale Fill Manual can be used for figures like box plots, histograms, etc. Anything where you would want to change the fill within your plot. So here I'm going to plot our same box plot with fill equal to species, and I'm going to use the color palette with 2 values since we have 2 species. So within the Scale Fill Manual function that I've added to our original plot, I'm going to set values equal to CB2. And this is what that looks like when I run the code. We have this dark purple here for our Acinetobacter samples, and this lighter green color here for our Klebsiella samples. Scale Color Manual can be used for figures like line plots and scatter plots. So here I have a scatter plot of largest contig versus total length, where the color is corresponding to the antimicrobial resistance profile. And so within the Scale Color Manual function that I've added to this base plot, our values are going to be set to CP4, the color palette I made with 4 values. And that's what this looks like here, where we have our Blah KPC3 positive samples colored in this burnt orange, our Blah Oxa23 positive samples colored in dark blue, our Blah Oxa23 and Blah Indium 1 positive samples in a light green, and our Blah Oxa72 positive samples in a dark, more olive green color. ggplot2 also has the ability to color our plots by a grayscale, and this grayscale function is called Scale Fill Gray and Scale Color Gray. So that's what these look like here, where we just add Scale Fill Gray, and we now have a box plot that's a dark gray and a lighter gray, or Scale Color Gray, where we have this shade of different grays available for our scatter plot. And if you want to take a look at the functionality for this, as always, we can use the question mark to take a look at what the parameters are and how to use them. Now, color gradients for continuous variables can be set using Scale Color Gradient or Scale Fill Gradient. I have an example of this here where I have our scatter plot where the color is in 50, which is a continuous variable. And we just add Scale Color Gradient to the plot. And now we have a plot of a continuous variable on a gradient here on our scatter plot instead of a discrete variable. We can use the high and low parameters to choose either end of the gradient, and ggplot2 will automatically create a gradient for us. So we can set low equal to this hex code here and high equal to this hex code here within the Scale Color Gradient function. And now we have this purple to green gradient that ggplot has generated for us. And we can also use the Scale Fill or Scale Color Gradient 2 function to create a gradient with a chosen middle color, which is also called a diverging color gradient. So within the Scale Color Gradient 2 function, I'm going to set low and high equal to the values I did in the last example, but I'm going to set the middle color equal to gray. And I'm going to say that the midpoint, which is our next parameter that we need to choose, is going to be the mean of N50. And when I run that, we now have a purple to green gradient of N50 where the mean value is gray. Next, we're going to talk about some color palette modules. There have been many color palette modules for R that have been written out there. These are just some examples. One really popular one is the R Color Brewer. I've included a link to all of these color palettes. First, we're going to load in the library, and then the function for R Color Brewer is Scale Color or Scale Fill Brewer. And R Color Brewer has a number of palettes you can choose from. So in this case, I'm setting the palette parameter to set1, and that's what these colors look like here when we plot that. There's also the Viridis library, which I'm a big fan of, and the link to that can be found here. So the function for using the Viridis package is Scale Color Viridis or Scale Fill Viridis, and I'm choosing the plasma option, so I set the option parameter equal to plasma, and because this is a discrete value, I chose, which is the antimicrobial resistance profile, I'm going to set discrete equal to true. If I were using a continuous variable, I would set discrete equal to false. And here we see we now have the Viridis color palette option here in our figure. And finally, I used this in a previous example on themes, but I'm going to use the Dracula palette from the library ggplot2. And to do that, I would use Scale Color Dracula or Scale Fill Dracula. And I need to set discrete equal to true because, again, I'm using a discrete variable, which is antimicrobial resistance profile. And that's what these colors look like. So finally, the last thing we're going to talk about for this section is saving our plots, because I've given you many, many different ways to plot things and customize those plots, but we actually haven't talked about saving our plots, and that's a key part of making a figure, is being able to save it and then put it in your report or your publication on your website, etc. And so the easiest way to save a plot made with ggplot is ggsave, and that's the function name. And ggsave will save the last figure you plotted to a file by default, or you can supply it with a variable you stored your plot in. And so this is the ggsave function, which we're going to explore using the question mark functionality. And it has all of the parameters associated with it and what those parameters are. I'm going to highlight a couple of the most useful ones, which are plot, path, width, height, units, and DPI. So first you need to give ggSave the name of what you want your plot to be. In this case, I'm just going to call it myplot.png. You have the plot parameter, which is, in this case, last_plot, which is a function, but we can also just leave this out entirely and it'll work the same. We have our pathway, which is going to be figures, because if we go here to files, we see that we have a data folder, a scripts folder, and I'm going to add a figures folder. And then I want to set the width of it to 5, the height of it to 5, and then I want to set the units to inches. And if we go back to the help tab here, we see that the possible units are inches, centimeters, millimeters, and pixels. I'm also going to set DPI to the default, which is 300. Choosing a DPI can be important depending on what you're going to use your figure for and if you have DPI constraints. The last plot we made was this scatter plot colored with the GG Dracula palette, and we're going to go ahead and save that. And because I don't have a folder named figures already, it'll say cannot find directory figures. Because remember, an alternate name for folder is directory. Would you like to create a new directory? And in this case, I'm not going to, because I'm just going to show you what happens if you don't do that. So we select 2. And as you can see, it throws an error saying, hey, this figures folder doesn't exist. So let's go ahead and run this code again. And it asks me again, I can't find this directory. Can we make a new one? And this time I'm going to say, yes, we can. So we're going to select option 1. And now it says, hey, we created that directory for you. And we go to the Files tab and see that we now have this directory named Figures. And within it is our plot, which we can click on, and it will pull it up for us. And it has been saved. So let's make a new figure and store it as my plot. And let's take a look at that. As you can see, it is a scatter plot colored by the plasma color palette of Viridis. And let's go ahead and save that as my plot. But this time we're going to set the plot parameter equal to my plot, unlike in the last one where we didn't specify what we wanted the plot to be. And as you can see, it worked just fine. However, it did overwrite it, so be aware that it's not going to warn you if it's going to overwrite a file. It will just overwrite it. So make sure you give your plots different names or store them in different directories. So that concludes this section as well as the entire webinar. Thank you so much for taking the time to learn ggplot with me. And as always, if you have any questions, feel free to reach out to me. Explore the GitHub where you can find these scripts and run them for yourselves. And I will see you in the next webinar.